It's my pleasure to introduce Kim. He's going to talk about owning the web. Thank you.
How's it going, everyone? So as web developers, we're hired to create business value and reduce business costs. Anything we can do to assist in that endeavour is going to go down well for us. The following set of tools I use often in research and security engagements. Reconnaissance is the act of information gathering. The quieter you can do this, the less likely you'll be to raise suspicions or raise your client's defences. Here we want to gather as much information that will be potentially useful for taking into the following stages, where we start to obtain more information about services and other software being used and their versions, moving from passive to more active techniques. We need to learn as much as possible about the people involved within and related to the target organisation. This way we'll be able to create successful pretexts, essentially becoming them. So Lee Bard's Discover scripts are a collection of shell scripts to aggregate Kali Linux tools and automate various penetration testing tasks, both passive and active options. And they allow you to dig up a lot of dirt on your target long before you even start trying to penetrate them. So I've found domain and person to be really useful. Too far. For example, recon domain passive combines GooFile, Googlemail, GooHost, the Harvester, Metasploit, DNS Recon, URL Crazy, Whoas, and multiple websites. Recon domain active combines Nmap, DNS Recon, Fierce, LVD, WAF, 00W, Traceroute, and WhatWeb. So rather than getting familiar with all of the reconnaissance tools, you can just get familiar with the likes of Discover scripts. I'd also recommend Maltego, which is another information gathering tool, but what it does is it basically it graphs the relationships between the information that it's gathered. So it's really important to have done a good job at the gathering information in the reconnaissance step. You'll know if you didn't do well at this step, and even more so in the exploitation stage, because you'll be wondering what to attack first. You'll be hitting machines and people with less vulnerabilities than others. An attacker will always be focusing on the lowest hanging fruit first, and so should you be. We start off using options that are as passive as possible to avoid triggering alarms with IDSs and savvy sysadmins. Nmap and scripts can tell us a lot, even when it's configured to scan really quietly. Metasploit provides the ability to scan many services. Last time I checked, there was 449 scanners. These are just the SSH ones. So you use the scanner, you set any options, you check the options, and you run it. With the results, you can feed into multiple vulnerability search tools, and often you can get canned exploits. The Open Vulnerability Assessment System, also known as OpenVAS, was forked from Nessus in 2005 before it went proprietary. It's accompanied with a daily update feed of network vulnerability tests. There's over 35,000 in total as of April 2014. It scans pretty much everything against known vulnerabilities. It does make a lot of noise though. And you drive it with a command line interface and a web user interface. And it covers the OWASP top 10, number 5, security misconfiguration, number 7, missing function level access control, and number 9, using components with known vulnerabilities. There's OWASP SAP, which is not only a great web intercepting proxy, but it's also really good for finding web vulnerabilities. There are many other good vulnerability scanning tools, and just not enough time to cover them all now. So now that you've got a good idea of which vulnerabilities you should be trying to exploit, you'll need to look for which exploits are going to work. Offensive security, which is the creators of Kali, have the exploit database, which has a web front end and a CLI. We've got security focuses bug track. We've got Rapid7, which is the current owner of Metasploit. They've got a database as well. We've got Node security advisories and the National Vulnerability Database. Then a pen tester will generally move on to the exploitation stage. The following tools are the main tools that I've used in this presentation. The Browser Exploitation Framework, also known as BEEF, exhibits cross-site scripting flaws and how serious they can be. In order to use BEEF, you have to get the hook.js, which is 24 JavaScript files concatenated into one JavaScript file into the web page and wait for the victim to fetch it. You can do it via a cross-site scripting vulnerable web application, or you can do it via cloning a web app. We use Social Engineering Toolkit for cloning sites and harvesting credentials. We use Ettercap for ARP and DNS spoofing and man-in-the-middling. We use Veil Evasion for evading antivirus. We use Metasploit for its huge database of exploits, sending stages and setting up listeners. So why these tools? Because they exhibit some of the most frequently compromised vulnerabilities on the web, and they allow us to demonstrate many flaws in the target code and infrastructure. They give us the power to redeem ourselves before we are made a public security statistic, and they help us to compel our stakeholders that mitigation is necessary. And by doing it, we'll save face and potentially a lot of money. So Demo 1 addresses the cross-site scripting vulnerable web application. So it could be a website regularly visited by your victim, or it could be a website you social engineer your victim to visit. So we start BEEF. And then we log into its user interface. And then we're going to exploit a cross-site scripting vulnerable web application. Some of you have probably already seen this. It's just a purposely vulnerable web app. So we turn on Foxy Proxy there, and then we fire up burp. And we're going to drop our BEEF hook.js into the request for that message. Fire that off. Don't need Foxy Proxy anymore, turn that off. Now a victim visits the XSS vulnerable website. Go to the same page that our hook now lives in. And the victim browser's hooked. And we can see the zombie browser are requesting commands from the BEEF communication server now. It's every few seconds it just polls the comm server asking for commands to execute. So we're going to execute a pretty simple BEEF module here. It's called Pretty Theft. It's pretty entry-level stuff, but it's actually quite effective, especially if you know that our victim lives on a specific site. So the victim, or victim-to-be, he's a victim post-exploitation now, enters kim@exploited.com and not very secure password. This is a modal. It could look like anything, basically. There's a few out of the box, like LinkedIn and a few others as well. And you'll see there the response. So what are some of the countermeasures? Fix your cross-site scripting vulnerabilities. This is a link to the holistic InfoSec wiki that I've been putting together for some training. There's a section called Wrongfully Trusting the Loading of Untrusted Web Resources. That's where that link leads to. That pretty much will go through everything you need. It's also got a link off to some OWASP resources. So Demo 2 shows a very simple way of obtaining your victim's credentials using the Social Engineers Toolkit. So first up, we check the public web-facing directory of our attack box. Make sure there's nothing in there. And we run Social Engineering Toolkit. We select number 1, Social Engineering Attacks. Number 2, Website Attack Vectors. And then the Credential Harvester attack. And we want to clone a site, so we're going to hit number 2. Now we enter the IP address that set's going to be listening on, that's the attack box. And then we want to clone accounts.google.com. So the host's cloned, and we have a PHP file sitting in the Apache web directory now. And set also asks you if you want to start Apache if it's not already running. And as we can see, that harvest file is currently empty. It's going to be populated soon. So the victim clicks a link that was passed to them via social engineering. This could be any site that you know the victim has credentials for. So the victim's going to enter kim@pentester.org and my insecure password. As soon as the victim posts, set uses the HTML referrer header, in which it intercepts a request that comes from the victim's IP address and harvests the posted credentials, and you can see them there. And the page redirects to the real accounts.google.com straight away. So set also provides the ability to craft emails with spoofed from addresses. You just need to install and configure sendmail. So again, what are some of the countermeasures? Don't click unsolicited links. It's our job to train users to what and how things can go wrong. Users need to become familiar with social engineering tactics to coerce them in order to protect themselves and other people they know. I discussed some of the tactics on my Holistic InfoSec wiki, linked to here. So it'd be nice if the URL looked legitimate, yeah? So this is using doppelganger domains. It can be quite effective. And there's usually a few options, all for the low price of $71.40. In this demo, we're going to add ARP and DNS spoofing to the mix. The idea is that we take advantage of the fact that we know which site or sites our victim likes to spend time at. So I ran set against superhero.js.com, just like we did in the last demo. And I wgetted the files that set doesn't fetch, because set only fetches the index file and sets it up for you. And then added those missing files into the public-facing web directory. So this is the index file that set cloned for us. We just needed to replace that Google APIs link and pull some of those files locally to reference, and now we just plant in the beef hook. Now we run beef and we add our A record to Wdcnz's DNS, and we run Wdcn with the man in the middle option, poisoning the victim and the gateway and using the DNS plugin. And then we log into the beef user interface. Now the victim visits the clone site that they like to spend time at, not knowing that it's a spoof site, of course. So the browser's hooked. And we can see the zombie browser continues to ask beef comm server for commands. So beef can also be used to clone websites. It's not quite as user-friendly as the social engineering toolkit though. So long as the target machine has a browser window open and running the beef hook code, the attacker has this window of opportunity to create a persistent connection for when the browser window is closed. So again, what are some of the countermeasures? Check out the spoofing countermeasures section on the Binary Mist wiki. It covers IP, ARP, DNS, website, and a few other different types of spoofing, and the tools that can be used to help protect against these types of attacks. Also keep your eye on the book that I'm writing. It's got a lot of this sort of detail within it, and I'm republishing continually. It's on LeanPub. So if you just search for Binary Mist, you'll find it and the name of it. Beef also has a REST API, and Beef's got the concept of extensions and modules. Extensions change how Beef behaves, and the modules change how the zombies behave. And Beef comes with a load of them out of the box, and you can add your own. These are some of the modules. Beef can be installed on a public VPS, any public VPS, so you can attack natted victims' machines from the Beef web user interface from anywhere. Amazon even has a policy for using their VPSs for penetration testing. There's a bunch of other public and free VPSs that you can use. I like free ones. There's also a number of ways to automate the running of modules on successful hooking. Beef provides the auto-run script, which allows a single module to be run. And there's also the Beef injection framework, also known as Shank, which integrates with Beef, allowing the running of many modules against many browsers concurrently. Now, when I first started to put this together, I was quite keen to cover WebRTC, but it wasn't one of the modules in Kali Linux at the time, and I was kind of running out of time. I got the guys at Offensive Security to basically pull on the latest version, but it all happened a little bit too late. It's there now and it's waiting to be tested. But I would like to encourage all not just to take technology at face value, but to think about how these things can be exploited. This makes us all much better programmers. So Beef has ways of getting shells in directly and indirectly, but let's look at some other options. Okay, so we start the database service, Postgres, which Metasploit depends on. Then we start Metasploit service itself. And then we run the social engineering toolkit, And we select social engineering attacks. And number 2, website attack vectors. And then number 6, multi-attack web method. And we want to clone a site again. Don't need port forwarding. We select the IP address that we're going to be listening on. And we clone accounts.google.com. And we turn on the Java applet attack and the Metasploit browser exploit method. And we select the vulns to exploit. Number 2, interpreted multi-memory injection. And we select the payloads to deliver. We're going to hit them with everything. And we select port 443, just to help disguise the reverse connection as legitimate. Then we encrypt the payloads and configure the reverse shells. And we take the easy option of using the built-in Java applet in set. Soon, here. And then we select Metasploit's autopwn for the Java applet browser exploit. And host the clone site and start MSF console. Now the victim features our spoofed Gmail site. Oh, and we've got a Java applet update. Yeah, so we're always supposed to keep our systems patched, right? We better run it. Yep, antivirus says we're all safe. Must be good. First PowerShell exploit fails. And here come the shells. Let's interact with the first one. Can we elevate privileges? Not this time. So we need priv in order to bypass UAC. So we can't actually get system on this shell, but possibly one of the other 2 shells we could have. And we only get the privileges of the user running the browser exploit. So all I'm demonstrating here is that we can, from the attacker, we can actually just create a file on the victim's desktop. But that's as far as we can go. We've only got the same privileges as the victim. We'll sort that out in the next demo though. Then we just check from the victim that the file's actually there. That's that. So demo 5. We start veil evasion. We list the available payloads to encrypt. Here we choose a service because we're going to be using PSExec to install it on the victim's box. We want it to be a reverse shell to us. So we set some options. That's just the listening box, listening IP, and generate it and give it a name. Then we're going to encrypt the payload with Hyperin. Hyperin encrypts with a weak 128-bit AES key, which decrypts itself by brute force at the time of execution. Now we're going to run Metasploit with a PSX exploit. These are the options we use. Now we've got the credentials from a previous exploit. There are many techniques and tools to help capture these, whether you have a physical access or not. We just need the username and password or the hash, which is often transmitted across the network for all to see anyway. Also easily obtainable if you've got physical access to the box. And we've got our shell. So let's interact with it. We're going to go straight to where the hosts file lives on the victim machine and just create a file beside the hosts just to demonstrate that we've got system privileges. Okay, so we're just going to echo some text into a file that lives in that location. Now, of course, the user or the victim doesn't actually have permissions to write to that directory. And we just check on the victim that that file was created. New hosts. Now we try and delete that, but we can't because we haven't got the privileges from the victim side. And then we do the same from the attacking side, and she's all gone. Confirm. So there are lots of ways of obtaining the target's password hashes and a few defense techniques. Long complex passwords, which are changed regularly. Disabling LM hashing, only accepting end-to-LM version 2 auth requests. Using the syskey Windows feature to help strengthen the encryption of the SAM file. And evaluate who has physical access to the box. Also consider social engineering. People are usually our weakest point. And for completeness' sake, few developers like documenting and reporting, but without it, the rest of the process is a waste of time. There are loads of tools like the Dratis framework, Magic Tree, which does data consolidation, querying, external command execution, and report generation. It's also good for the information gathering stage. Find what works for your team. Thanks.